Hi guys, welcome back to another video of me teaching, and today I have this question on the board for you guys. So why don't we just get into the question? Well, this is actually a part 2 of this question, and if you haven't watched that, make sure to go watch that. But for those of you who have watched it, we know that in part 1 we have split this capital Pi up into two separate products, one ranging from 0 to 4 and the other from 0 to 6. And I said for us to sort of ignore the outer terms, which is this and this. And to do that, I let this term just to be a variable x. So now we also let this inner product to be a polynomial g of x. So today our goal in this video is to find this g of x, which has roots of -4 cosine squared of 2 pi t over 7. Okay, well, finding a polynomial with roots of -4 cosine squared 2 pi t over 7 seems sort of complicated, right? But I think that it'll actually be much easier if we try and find a polynomial p of x, say, that has roots of 2 cosine of 2 pi t over 7. And if you have noticed, this is actually just the square root of this. Okay, so if we want to try and find a polynomial p of x with roots this, my first step is I'm going to let this thing, 2 pi t 7, to be equal to theta. So this just becomes 2 cosine theta. Now, we want to find a polynomial such that its roots are in the form of 2 cosine theta. Now, what polynomial is in your mind right now? Well, in my mind, I'm thinking of the Chebyshev polynomials. But of what degree? Well, I think it should be T7 of cosine theta. And if you don't know what that is, I've already explained that in my previous video. Anyways, I think it is T7 cosine theta because if we see here, cosine of 7 theta will just be 1. And I'll write that out for you guys. So T7 of cosine theta, which is equal to cosine of 7 theta, is equal to 1 because of this. So what we want to find is T7 of cosine theta. But here we have 2 cosine theta. Well, an easy fix for that is this. We can let this to be some x, and we know that cosine theta will just be x over 2. So we have to find T7 of cosine theta, which is also T7 of x over 2. So T7 of x over 2. And lucky for us, I've already written down what T7 of x is here. So all we have to do is we have to plug in x into 1 over 2 times x into here. And this will just be equal to 1. But we want this side to be 0, right? That's what makes it a polynomial. So what we can do is we can subtract 1 from both sides. So this becomes T7 of x over 2 minus 1. And this also becomes minus 1. Okay, so we see that this is quite ugly, right? Look at how many fractions we have. Well, what we can do is we can multiply it by 2 on both sides. So it becomes 2 times T7 x over 2 minus 2 is equal to x to the 7 minus 7x to the 5 plus 14x cubed minus 7x minus 2. Okay, so now what should we do? Okay, and the polynomial that we have here is a polynomial with roots of 2 cosine of 2 pi t over 7. Now, because of this, we can easily write this in capital Pi notation. So I'll write this on the left-hand side instead. So it becomes capital Pi when t goes from 0 to 6 of x minus 2 cosine 2 pi t over 7. Okay, so now I'm going to rub everything out, and then we'll try and start manipulating this capital Pi into this g of x. Okay, so now I've rewritten this up here, and in case you forget, I also wrote what s is on the left. Okay, so I'm just going to make this into equation 1. And then I'm going to introduce to you a fundamental theorem about polynomials. So the fundamental theorem is, if we have a polynomial p of x, and this is not the same p of x as we had just then, this is just a general polynomial. If we have a general polynomial p of x, and we can write it in the form of a, or some constant, multiplied by capital Pi, when I goes from 1 to n, of x minus alpha I, then we can replace x with whatever we want. For example, we can get p of f of x. And this is equal to, same thing, a times capital Pi, I goes from 1 to n, and then we just have to replace the x with our f of x. So with this in mind, then we want this to be the same as this, right? But right now, we're a far way off. But if we can see, if we can multiply by its conjugate, then it'll be closer, right? At least this term will be correct. So how do we make its conjugate? Well, just then I explained to you that fundamental theorem about polynomials. So what we can do is, we can just replace the x with negative x, right? So the left-hand side will become capital Pi t goes from 0 to 6 of negative x minus 2 cosine of 2 pi t over 7, right? And then the right-hand side will be, okay, so now that we have this, I'm going to call this equation 2. So now, to make the conjugate, all we have to do is we have to change this into x plus 2 cosine of 2 pi t over 7. And an easy way to do that is to multiply both sides by negative 1 7 times. Why 7 times? Well, because this product has 7 terms. So each of the negative ones can be multiplied into each of the brackets. So the left-hand side becomes capital Pi, when t goes from 0 to 6, of x plus 2 cosine of 2 pi t over 7. And now the right-hand side will be, since we multiplied by negative 1 to the power of 7, we basically just inverted all of the signs on the right-hand side. So it becomes and I will call this equation 3. So now what we can do is we can just multiply equation 1 and equation 3, so we can get something that is even closer to this. So equation 1 times equation 3, this implies that the left-hand side will be this times that, which is the capital Pi will stay the same, t goes from 0 to 6, but the inside will be something plus something times something minus something will be x squared minus 4 cosine squared of 2 pi t over 7. Okay, and the right-hand side will be, this is going to be very complicated since we are multiplying this whole thing by this whole thing. Okay, and I will call this whole thing to be equation 4, right over here. Now, you might think this is super complicated, but later in the video, that will be okay. Okay, so now I'm going to rub everything out. Okay, so now that we have this, what we can do to make it into this is we just have to do the exact same procedure. Make x squared into negative x and multiply both sides by -1 7 times. And I will put those two steps into one because then it will take me so much writing. So we see that in the end, this whole thing will become capital Pi, t goes from 0 to 6, of this, x plus 4 cosine squared 2 pi t over 7. And the right-hand side will be equal to, so once we replace x squared with negative x, since these are all even terms, then these terms will go from 14, 12, 10, 8, 6, 4, 2 into 7, 6, 5, 4, 3, 2, 1. So this becomes, okay, so this is what it'll be. And then now we see that this is just g of x, right? So is this a final answer? No, because remember, if you forgot, you can look here that s is capital Pi when s goes from 0 to 4 of g of x. Okay, but before we get to that, I'm first going to clean this up. So I'm going to rub this out. So we can't just go in and plug in g of x, which is this, into this big mess, right? We have to at least try and factorize it. Now, factorizing this will be very hard, so I'm going to make a separate video in depth about how to factorize this. But in this video, I'm just going to tell you the final answer. So g of x in factorized form will be equal to, okay, so this will be g of x as its factorized form. Now I will get onto this. S is equal to capital Pi, s goes from 0 to 4 of g of x. So this right-hand side will just become capital Pi when s goes from 0 to 4 of g of x, and the x is just this, 4 cosine squared 2 pi s over 5. Okay, so now that we have this, we see that this product goes from when s is 0 to 4. So there will be 5 terms multiplying together. What will be the first term? Well, when s is 0, this becomes cosine of 0, which is 1. So it becomes g of 4. Then we multiply by when s is 1, so it becomes g of 4 cosine squared of 2 pi over 5. And then when s is 2, it becomes g of 4 cosine squared 4 pi over 5. And then when s is 3, it will become g of 4 cosine squared 6 pi over 5. But that is equivalent to g of 4 cosine squared 4 pi over 5. And similarly, for when s is 4, g of 4 cosine 8 pi over 5 is equivalent to this term. So we can basically raise this to the power of 2. And now, this will actually be the end of part 2. Okay, and to make things just a bit clearer for you, I'm going to just write s equals to this. So this will be the end of part 2, and in part 3, we'll try and use some smart techniques to try and solve for s. So, thank you guys so much for watching, and if you enjoyed my video and you want more videos like this, please consider liking and subscribing. If you want to master something, teach it.